similar as is very easy. Kubernetes commands are different. It's like a complete tool. And also Docker Swarm, like you don't have auto scaling, rolling updates implemented, whereas zero downtime is possible in Kubernetes. Zero downtime possible in Kubernetes, whereas that's not possible in Docker Swarm. These are some of the differences we have, right, about the Docker Swarm and Kubernetes, and there are many other differences. With respect to architecture, we'll look into them as we progress. Let's look into the architecture of Kubernetes. I'm sharing the architectural diagram. Kubernetes architectural diagram. So here you have a cluster, and this cluster can have any number of nodes. This is the control plane, and this is the worker node, right? This is the worker node 1, and this is the worker node 2. There could be any number of nodes. Here we are having 2 worker nodes and 1 master. This is called control plane of the cluster, which would manage the entire cluster. And if you look into different components on the worker node, you have different components. Like the first component is the Docker. Yes, to run the Docker containers, definitely you should have the So you should have Docker running. So that's a Docker runtime. And then you should have Kubelet. Kubelet is the Kubernetes agent running on every machine. And then kubeproxy. Kubeproxy is the network brains of the cluster, which would be taken care by this component. Kubelet is the Kubernetes agent. Whenever master have to give instructions, it would interact with the kubelet. So these are the 3 components which runs on every node. And then comes another important called pod. Pod is the layer above your containers. It's a layer of abstraction in which your container lives. In simple, in Kubernetes cluster, you will never see a container like this. Always your container, you will never see a container like this. Always your container would be wrapped around a layer called pod. Right? It would be always wrapped around a layer called pod. So, this is the layer of abstraction. Like you have containers, you directly deploy the containers in any other cluster or in Swarm, but in Kubernetes, you deploy the pod. Pod is the basic fundamental unit. You deploy the pods, you scale the pods, you delete the pods. You never deal with container directly. A container like this never exists. That's a layer of abstraction. This layer of abstraction is helpful so that you can run any pod. It could be, you could run any container. This container may be a Docker container, Rocket container, whatever container it is. It could still run the same way. That's how it provides a layer of abstraction, which is the pod layer, right? So Docker container, kubelet, kubeproxy, these are the different components, and then you have got the pod. Right, so that's how it works. So these are the 4 components you have in pod, Docker, kubelet, kubeproxy, and the pod. So now coming to this, you can have multiple containers in the pod, but one container is the general practice. One container per pod is the general practice. Also, in a container means every pod will be assigned with some IP. Container inside the pod will share the same pod IP, the same pod network interface. This pod is like a home for the container. It provides a living environment for your container, right? That's how it is with the different components, Docker, kubelet, kubeproxy, and so on. And yeah, that's how these components exist on every worker node. And then coming to the master node, again, there are different components here, like API server, scheduler, controller manager, and HCD. So if you look into the API server, the first component, API server is like the brain of the cluster. If you consider this API server, it's a core component and it's called brain of the cluster, which is a decision maker. And whenever you run the manifest file, actually here Kubernetes definitions could be run from the CLI or the UI, but UI is very rarely used, very less used. CLI is the one we'll focus. So in whatever way, whenever you give the input, right, it would be fed to the API server. API server will validate the input, right? It will validate, it will understand the input, and it will, like once it validates, it would interact with other component called scheduler. Scheduler, as the name says, is the component which will schedule it. Like at what time pod should be started, where a pod should be started, at what time, kind of scheduling will be done by the scheduler. Once it is scheduled, it would be then taken care by controller manager. Controller manager is like, which will have all the controllers, like node controller, replication controller, endpoint controller, and so on. Right? You have different controllers which will do this. So these are the different components you have. API server, scheduler, which will schedule the components, controller manager, which will have different controllers. And then HCD. HCD is like, how does the scheduler, controller manager get the details from? They get all this information from HCD. HCD is like a key valued pair, where the data is stored in the form of key and values, right? It would be having a key where data would be stored. So you have something like this, right? Key valued pairs, data is stored in the form of key valued pairs. It's a NoSQL database. Because for scheduler to schedule on a particular node, it should be knowing where a pod should be scheduled, on which node, at what time, what are the resources available. Even controller manager is like a, it's having so many controllers. We can say this controller manager is like a which will have all the controllers, and which will have some watch loops, which will be running some unending watch loops, non-terminating unending watch loops, which will keep on running to check if the expected state is as per the actual state or not. That's how you'll have the controllers, where the expected state is compared with actual state. Means, let's say you have configured, or you have given the input as you should have 5 containers. But actually, if you see 6 or 4, which is not as expected, it will identify it. Because like I said, it will be running non-terminating, unending watch loops. And it will identify this. Once it identifies this, right, once it identifies the expected is not as per the actual, it will send the information, like the scheduler will get that information. And as the information it's getting from HCD, HCD is like a memory of the cluster, right? It gets the information from HCD, and when it finds some abnormalities, it will be sending it to the scheduler. Scheduler will schedule the components to the work cutouts. How it will schedule? By interacting with this kubelet. I told you, right? It is the component which will interact. So kubelet will be scheduling it. Got it? Everyone understood? Any questions? This is the architecture of Kubernetes cluster, a bit different architecture. We could set up the cluster and see.
Actually, I have a question. What is the use of Q proxy?
Networking, communication between the pods across different nodes, communication between the pods and the node itself, all of that networking will be taken care by Q-proxy.
Okay. And this control manager have all kinds of controllers. Endpoint controller and other controller. So it will. So what all controllers it have actually?
Whatever objects we have in Kubernetes, you'll have those many controllers. Like what are all the objects you have, we will see those objects. So like, let's say you have pods, deployments, services, and all, endpoints, replicas. So you have controllers for all of those objects.
Okay.
So this is the architecture of Kubernetes. So coming to the setup, this cluster setup can be done in different ways, particularly Kubernetes cluster setup. This can be done in multiple ways. Like you may set it on-premise setup, or else, even though setup differs, commands are same, but the setup would be different. On cloud, like you may have it on GKP. GKP is a service on Google, which will help us create a cluster EKS, or else first let me write here clouds. Do it on-premise setup, Google GCP, Google Cloud Platform, AWS, and Azure, and so on. So if you come to on-premise setup, this is a bit difficult setup and a complex setup where you need to configure everything from the scratch. Right here, you will be configuring everything from the scratch, like including creating the master node, and so on. Like you have to create a master node here, worker node, all the components should be installed from the scratch, which is quite complex. And coming to GCP, this offers, of course, again, this can be implemented from the scratch, and there is also utility called kubeadm, right, with which you can spin up the cluster very easily from the scratch. And there is something called GCP, Google Cloud Platform, which offers a service called GKE, Google Kubernetes Engine. With this service, you can create a production grade cluster with a single click very easily. You can create this very easily with a single click. Right, and this is a production grade cluster. Also, this is free. Kubernetes is initially a product of Google. So it offers this service which we can use. And likewise, every cloud provider offers the service. Like if you know one service in a cloud, there would be similar services, right? Similarly, in the same lines, in AWS, you have something like EKS, Elastic Kubernetes Service, where you can create a cluster, a managed cluster. So which is a paid one, right? This is a paid service. Here, yeah, there's a paid service, but here you can explore all of it. And in reality, in the market, almost 50% of the Kubernetes clusters are EKS clusters, right? So this is one way. Again, in Azure, you have AKS and so on. So here what we'll do is we'll set up this on-prem kind of setup. First, we don't have on-prem machines, right? We will take some EC2 VMs, but we'll not use any managed service. We'll assume them like some standalone servers, and we will set up the cluster with kubeadm. Before working with any of these services, if you know this kind of setup, it would be easy for you to understand these things, right? Also, these days, on-prem kind of cluster setup is gaining importance. Professionals with this knowledge is having huge demand because of the cloud costs and all. Companies are migrating to on-prem. So having this knowledge would be a beneficial. So on-prem cluster setup, and you have GCP, AWS, and Azure. And first we'll get started with on-prem kind of setup here. And we will learn all the Kubernetes concepts. Means see, whether you set up on cluster on GCP or AWS, concepts, commands would remain same. So first we'll set up this cluster and we'll learn almost everything. But certain features cannot be seen with this type of setup. For those features, we'll go for EKS. EKS, like I said, it's a paid service. Yes, I'll show this as well. With all the missed features which we load balancer services, I'll show you here. So that way you will get exposure to both. Whether you do this hands-on on EKS or not, it's up to you. You may watch the recording, that should be fine. But if you are interested, you can take a call on that. Right? So we'll start with on-prem cluster setup. On-prem cluster setup would take some time. So yeah, let us do this. Good to go, or any questions from anyone? So, okay. So that's about this. So let us set up the cluster. Let's go to it. Let me create two new instances. Let's not use existing one. Let's create two new instances. I'm creating two. One would be acting as a master. The other one would be acting as a like worker node. So Amazon Linux to V2 Micro AWS. Every one instances. Let's name this as master. Worker node. So let's connect to them. This is the master node. Let me connect to the other node as well. So this is the master node and this is the worker node. So this is the master node. So first, on this master node, we have some prerequisites. It's not mandatory, but the prerequisite is like Am I audible?
Yes.
Okay, so the first thing is like let us change their host names. I would like to change their host name as master and worker. So this is the I'm changing their host names. This is the master as master node and the worker as worker node one. Let me add the IP address so that I'm adding these entries in the host file so that they should resolve the host names with each other. This is the master node. Let's add the entry for the worker node as well so that they should resolve their host names with each other. So to the worker node. Worker node. Okay, now let's go to host. So let me copy them again. Okay, let me save them. And disable the security in Linux in both the machines. Like, this is specific to CentOS systems. SC Linux will be not allowing the host to connect. So I'm disabling the security in Linux. And as we made some changes, reboot the instances. Like we change the host name, we disable the SC Linux. So let's reboot the machines. And once it is rebooted, we'll install it. Let me check if it is working. So yeah, we got back. Now let us install it. First of all, we can't install Kubernetes directly from yum repositories. So I'm creating yum repos kubernetes.repo file. This is the file I'm going to create, Kubernetes repo file, from where it has to download. Now that we got it, we can install it. We need here 4 components. Docker, as it is the runtime. So we'll install Docker. And then kubelet. Kubelet is nothing but the Kubernetes agent running, right? So your API server would be interacting with the kubelet. So this is the component we need to install. And also kubeadm. Kubeadm is the utility which will help you install cluster with all the components. So that is one thing. Another one is kubectl. Like kubectl is nothing but Kubernetes command line utility. You may create your cluster on AWS or Google or anywhere in any method. Kubectl is the way to interact with the cluster. So these are the components we are going to install. And when you are installing them, also install this particular version. There should be compatibility checks. So install this. And install them on both the machines. I'm installing on the worker node as well. So yeah, all the components were installed. Now let us start the clusters. Cluster starting would be like kubeadm init. You have to run this command on the master node. Also, one more thing is the basic or the minimum requirement to be a Kubernetes node is it should be having 2 GB of memory and two vCPUs. But T2 Micro has got only one vCPU and 1 GB of memory. For our lab, that should be fine. In that case, whenever you are running this, you should be running it by ignoring those errors. Otherwise, if you just run this, it will throw an error saying that the CPU and memory are insufficient, right? So what we would do is, we would run this by ignoring those flags. So go to master and run the command kubeadm. Kubeadm init API server advertise the IP address and the number of CPU and the memory flag. Right, let us run this way. And it got an error, invalid C. What is that? Kubeadm init IP address, ignore pre-flight errors. See, ignore the errors regarding CPU and ignore errors regarding memory. What's wrong in here? Let me check the private IP of the master. Please correct. Cannot connect to Docker is installed. Oh yeah. One more thing. Before doing it, you should start and enable Docker. Right? Docker and kubelet should be running before this. So let me start Docker and kubelet. Also enable them. They should be running before this. So let me do the same on the worker node as well. That's what it's saying. Docker cannot be started. See here, Docker daemon cannot be started. So start that first and enable both Docker and kubelet. They should be running before you start your cluster. So let's wait till it comes up. So it says, yes, cluster is ready, right? And it's saying this is the token you need to run on the worker node. So let's copy this token and run this on the worker node. That should be added to the cluster. Okay, we need to put this properly, removing the gaps. So let me just change this gaps and put this properly. Discover. Token, discovery token. And let's wait till it comes up. And meanwhile, yeah, we are running and creating this as a root user. We can create, or we need to connect to the cluster as a regular user. So whenever you create a cluster, see in this path, etc kubernetes admin.conf file is created, which is useful for authenticating. If you want to connect to the cluster as any other user, this conf file should be available in the kubeconfig folder. So let us create that. I am exiting as a root user. I become a EC2 user. So create this directory called .cube as a EC2 user and copy this admin.conf as a kubeconfig file. Kubeconfig file is required to connect to the cluster. So kubeconfig file will be created. Now give the permissions. Now EC2 user should be able to connect to the cluster. If you run CTL get nodes, it should be able to. And yeah, I got the issue. See, it was staying back here because it would be connecting on port 6443. We did not allow that port. That's the reason it would give a timeout error. Let me add those ports, or I'll add all traffic for them to connect. Let's add, I'm adding all traffic. Anywhere. Save this, right? So now we'll check back here. Yeah. See, now it got connected. Do you see that? It's done. It says that this node has joined the cluster. So just come here and run the command. Earlier only one node, but now you could see the other node join the cluster. Do you see that? kubectl get nodes, and you can see this, right? Perfect. So yeah, it is ready. Now there is one more thing left out. For them to get into ready state, we need to install something called network plugin. There are different network plugins like Calico, network plugin, Flannel, and so on. So we need to install the network plugin for it to work. So let us install this network plugin now. We are using Calico network plugin. So let me install the network plugin. Right, done. Now you see it should be able to, nodes should be in the ready state. Get nodes command will list the nodes in the cluster. It was a bit slow. Right, so your nodes are ready and they were available now, right? So you could deploy anything over here. So that's how you have this. Also, one more thing, whenever you deploy it, yes, the components, whichever we discussed, like API server, controller manager, etcd, they were all installed in the form of pods. You can check all the pods with the -C. They were all installed. See, your components were installed as the pod, right? Anything would be installed as a pod. You would install, you would understand this more as we progress. Just leave this. And now if you see the pods, there were no pods deployed yet. Now you can deploy your pod. From here, deploying the pods, containers, like actually container would be deployed as a pod, right? All of that begin. Any questions in this part from anyone? You should keep the documentation with you. Like you have the complete documentation available here and do this very carefully. If you go to this folder, Kubernetes, here you have the complete documentation with all the steps clearly given here, whatever I have executed. So follow this and execute this slowly. You should follow this and execute it carefully, right? So that's it. Like any other notes, whenever like you are doing hands-on on this, and if you're done, just stop them and start them. Again, your cluster should be working, loading a bit slowly, but yeah. So if you're all good, yeah, we can start deploying a pod. Actually, Kubernetes prefers declarative approach. Like you have to write a manifest file. Manifest file would be written again in YAML. That's how we deploy. But if you want to quickly deploy something, create pod name is sample and the image from where it is coming. Let's say I would use some image called nginx. This is the imperative commands for quick execution, but this is not preferred in Kubernetes. Always declarative approach is preferred. I'll show you that as well, but for now, let me show this. Uh, One second. Okay, kubectl run. It's not create. Kubectl run. No need of pod. Simply kubectl run sample pod and then image flag is correct. Right? That's how. See, pod is created. Kubectl get pods will show you the pods created. Right? See, it's in container creating state. Slowly it should be into the running state. Do you see that? Also, if you want to run where it is running, remember on Kubernetes cluster, always pods would be deployed on the worker nodes. Master would not be taking up any load. See, it's on the worker node. We have only one worker node. It's on the worker node, and this is the IP assigned to the pod, right? You could check this way. kubectl describe pod so that you could see all the details like the name of the pod. We did not mention namespace, so default and so on, container ID, image, everything. And here at the end, towards the events, you can see like pod is scheduled through the default scheduler. It's pulling an image called Nginx. This is how you can see all the details, how it's working. Default scheduler scheduled it, and the kubelet is pulling the image and starting the web. So this is how you will see whatever we discussed. Deep scheduler is assigned do it, then kubelet is helping pull the image, start the run. So that's how you can look. This is the imperative approach, a single line command, but this can't be reused or saved, right? We need a history of what are happening. So we would create a manifest file for this. So how to create a manifest file, how to deploy them and all, we'll see in the next class. Any more questions from anyone in this part? So like I said, if you are done with it, just stop them and you can start them and use them as a cluster again, like any other nodes. All right, then we'll close here and we'll continue in the next day. Thank you all. Have a good day and happy weekend. See you on Monday morning. Bye, everyone.